how to find out square root of any real number on the number line. And we are going to focus on mostly irrational numbers. Let's find that out. So we have seen earlier how to find out square root 2 on the number line using the unit square method. Then we have also seen how to find out square root 3 on the number line. So one simple way to think about how to get square root of any number on the number line is as follows. So let's say we want to find out the square root of the number n, where n is any real number. We are trying to find out square root of this or square root n on the number line. So what we are going to do is we are going to first find out square root of n minus 1. So for example, let's say we want to find out the square root of, say, 7. So what we are going to do is first we are going to find out where is square root of 6. So in other words, let's take a look to see how actually this works. So let's say this line as shown in red is square root n minus 1. So if line this, let's name it. Let's say this is A and this point is B. So let's say AB is equal to square root of n minus 1. Then what we do is at point B, we are going to draw a perpendicular line of 1 unit. So this measure will be 1 unit. Next, what we do, we join A and the end of this line. So let's say this line is C. In other words, BC is 1 unit. So BC equals 1 unit, right? And this angle is 90 degrees because it is a perpendicular line. Then when we join AC, AC represents square root n. So now the only thing we have to do is how do we get the length AC onto the number line, right? So we are going to use the compass example that we did when we were looking at square root 2 and square root 3 on number line. So we are going to put the fixed end of the compass here, then we are going to stretch out the other side, and then we are going to assume like this is the radius of our circle, and then we will draw an arc which will look something like this. So then let's call this point here B. So this length AD will be equal to square root of n. So a quick recap, if we want to find out square root of any real number, in our example let's say 7, so we have to first know what is square root 6. So in this example, let's assume AB is square root 6 as shown in red. If AB is square root 6, then at point B, we draw a perpendicular line and we find point C such that BC is 1 unit. Then we join AC, then with A as center and the radius as AC, we draw an arc that cuts the number line at point D. And AD will then be square root n, or in our case square root 7. So why does this work? So the reason this works is because if you look at the triangle ABC, right? If you look at the triangle ABC, what we have is AB equals, like we said, AB is equal to square root of n minus 1, right? And BC is equal to 1. So the length AC by Pythagoras theorem will be AC square equals AB square plus BC square. Why is that? Because ABC is a right triangle and AC is the hypotenuse opposite to the 90-degree angle. So hypotenuse square equals sum of squares of the other two sides. Now, what is AB? AB is square root n minus 1. So if you do AB square, it will be just n minus 1, right? So it will be n minus 1. AB square will be n minus 1. Plus, we have BC is 1 square, which will be 1. So what we have, let's write it over here. So we have AC square equals n minus 1 plus 1. N minus 1 plus 1. So minus 1 plus 1 cancels out. We are left with n, or we say that AC equals square root n. Squaring both sides, square rooting both sides, I should say. AC will be equal to square root n. So if AC is square root n, then using the arc way, we basically get the length AC onto the number line. And if this cuts at point D, it is AD. It is AD. AD equals square root of n. So I think one big drawback about this method is that in order to find square root of n, we really need to know square root of n minus 1. In other words, if you were to find out square root 7, you have to find out square root 6 first. But in order to find out square root 6, then you need to find out square root 5, right? So the higher the number, the more square roots you would need to find as to where those square roots are on the number line. Is there an easier way? There actually is, which is what we are going to discuss next.